So if we are good with this, let us go for the setup. Kubernetes cluster setup can be done in multiple ways or multiple platforms. Like let's talk about, you can do the setup on-premise, or else you can do the setup on any cloud. Any cloud could be like a GCP, Google Cloud Platform, or it could be AWS Cloud Platform or Azure or any other cloud platform. First, let's talk about on-premise setup. On-premise setup is the complex setup out of all. Right here, here you have to configure everything from the scratch. Means you have to install those components whichever we have seen individually and connect them, and that's how the setup is. Or else, like the raw method of setup, or else that's very complex. Or else you have something called kubeadm, okay, which will help you, an utility which will help you set up the cluster with all those components. So that's one way. Here, what we will do is, this is the very, very important type of setup and the complex type of setup, which is used, like even though the big MNCs or gigantic companies, they will even have their own cloud, right? Private clouds. And they will be setting up their own clusters as well, because to compensate the cost on the public cloud and also security and various reasons, even they will have their own cloud. And premise setup is very important. And particularly like startups sometimes, because of to compensate the cost on cloud, they would be choosing this. And when we go for this on-prem kind of setup, definitely a lot of experience is needed to to set up this kind of cluster. And definitely this will have like a architect level kind of, will be working on this kind of setup. Yes, we have kubeadm through which you can do the setup. So, and also if you understand the setup, you can understand other cloud setups easily. So first what we'll do is, we'll go with the on-premise kind of setup with using kubeadm, right? But then we don't have on-premise, right? Or else I have my own machines. Like what we will do? We will again use EC2 instances only, but we will not use any managed services, but we'll see the raw way of setting up the cluster using kubeadm. That's the first way we will do, right? So here we will learn all the cloud, all the Kubernetes concepts. Then if you go for GCP, GCP offers a service called GKE, Google Kubernetes Engine. And if you remember, we discussed Kubernetes is natively a product of Google. Hence, it offers this GKE, Google Kubernetes Engine. It's like a just a top up, or else it comes with a pre-package with everything. You can create a cluster with a single click. Even the production grade cluster can be created with a single click, and this is free. This GKE is free. See, when I say free, this GKE is free. This service, this managed Kubernetes engine is free. And at the back end, you might be using some instances for it, right? They will be again charged. You will be charged for it. But even then, this service is available for free. Yes, you can learn all the Kubernetes concepts here for free. Then like we learned, if you know one service in any cloud, all the services, there'll be similar services on different clouds, and that's how you can draw the analogy, right? Now, let's talk about this. On AWS, you have a service called EKS, Elastic Kubernetes Service. This is also a managed service with which you can create a cluster easily, but not with a single click, but you can manageable. You can create a cluster with EKS. It's not too complex or not too easy. It's a medium level of complexity. You can create a cluster with this, and this is not a free service. This service is paid. EKS service is paid. On top of it, you may be using some worker nodes, you may be using some load balancers. All of them will be charged separately, right? I will be covering this as well as an example to cloud, as an example of EKS or Kubernetes service on cloud. And remember, out of all the clusters in the world, 50% are EKS clusters. You can imagine how important this is. 50% of the clusters are EKS clusters, right? So that's why I'd be covering the on-prem setup so that you will understand actual concepts or like the basics of creating a cluster, and then you will understand the CKS. Similarly, in Azure, you have AKS and all. Like I said, if you know one service on one cloud, there'll be similar services and you can draw analogy easily. I wouldn't say exactly same, but yes, concepts are similar. Analogy would be similar. Like you have EKS here, you may be having AKS, and so on. Similarities would be there. So this is the agenda. We'll be getting started with on-premise kind of setup with kubeadm. We'll learn all the Kubernetes concepts here. Actually, in reality, you can use all the production grade features in this kind of setup. There is no limitation. But with the kind of setup we do, right? We use some EC2 instances and we do it, right? So for this kind of lab setup, there were certain limitations. Like we cannot see load balancer service, we cannot do auto scaling. Such features which we would be missing with our kind of lab setup, those we will see on this AWS. Sorry, on this EKS, auto scaling and what is the other one? Load balancer service and all. In reality, don't think that, okay, on-premise, you don't have it. You can do it, but with our lab setup, we can't do. So whichever we can't do on on-prem, we will do it here so that we will cover both of the services. If you know one kind of setup, you can work with anything else. Are we good with the plan?
Yes.
So let's begin with this now. Today we'll get started with setting up our cluster with kubeadm. I'll be creating a cluster, a 2-node cluster. One is a master, the other one is worker, one worker. You may have multiple. So I'll be creating a 2-node cluster, one with a master and one with a worker. These are again easy to, but I wouldn't use any managed services. I'll just use kubeadm, assuming those are the like individual or standalone nodes, and we'll start the cluster setup. Once only the difference is the cluster setup. Once clusters are set up, the concept of pods, how do you work with the Kubernetes objects, deployments, high availability services, all of that remains same. So let's begin with the kubeadm setup. So let me create 2 nodes. And by the way, to become a node in the cluster, the minimum prerequisite is first, the minimum prerequisite is it should have 2 vCPU and 2 gigs of memory. See here, T2 micro will have only 1 vCPU and 1 gigs of memory. It should have 2 vCPU and 2 gigs of memory at least. 2 vCPU means you should go to T2 medium, which is not free. So what we will do is for our deployments, this is enough T2.micro because we can clean up the cluster regularly and utilize the resources generously so that it's like we will be going with T2 micro, but it will not allow to create a cluster with 1 vCPU, but we will override those during the setup. Okay. So T2 micro, Linux 2, T2 micro, key pair is AWS, T2 micro, Amazon Linux 2. That's all. And also, let's have 2 instances. So let's create those nodes. So let me name them as master. It's actually not master. We have to make it as of now just a cluster, but as I want to make it a master, I am naming it as such. Haven't I started 2 nodes? Okay, it's coming up. Right. So this is the worker one. Okay, now let's connect to them. There were some prerequisites we need to go through. All those steps are given in the drive. Here is the steps in your Google Drive. Every step is given here very clearly. So we'll follow them. First, let's connect to master node. So this is going to be the master node. Let me open one more. Let's get the worker node. This is going to be the worker node. To identify this, let me put a different background color for this. Okay, that's a worker node. So yeah, this is the master node and the worker node. First, let's go through this. I'm going to set the host name of the master node as master node. It's not mandatory, but to identify this, I'm just putting some host name. Same is the case on the worker node. And do this setup carefully, okay? At least initially, do it step by step. Copy the commands and do this carefully, okay? Because if you mess up this, fixing the issue would be a bit difficult. Later on, you can experiment and try and spend some time on fixing it. At least in the initial days, go through the commands as it is and do the setup successfully so that without interruption and without loss of time, you could get on to hands-on. Later on, second time or third time, you can experiment other things if you want. Okay, first thing is set up the host name and then they should resolve their names with each other. Both of them should resolve their host name. So add those entries in the etc host file. Like on the master, etc hosts. Let's add those entries here. Like master nodes private IP. Master nodes private IP. And then the host name. And then worker nodes private IP. Right? So added those entries, copy them, save this, do it on the worker node also. Etc host. Save this. Right? So we have added those entries so that they should resolve their host names. And another thing is set enforce 0. Set enforce 0 is relevant to CentOS or Red Hat systems, means it's OS specific command. Set enforced 0 means there'll be something called security in Linux. Security in Linux should be disabled for the host, for these nodes to communicate in the cluster. So this should be disabled and this is OS specific for Red Hat and CentOS based systems. So disable this security in Linux. And then reboot the machine so that all the changes should be into effect. Like we changed the host name, that should be updated. SC Linux is disabled, that should be updated. So reboot the machines once done. Once it is restarted, we will get to install some components. What components we need to install? We will be like, if you remember, we were talking about these components, right? You need to have Docker installed. Correct? Docker should be running as you run the containers or in pods. You need to have Docker installed. And then you should have kubelet installed. We will install these components. Apart from this, you would be also installing kubeadm. Kubeadm, like I told you, right? It's nothing but utility with which you can create the clusters, you can destroy the clusters, you can manage your cluster. So we'll install kubeadm. And then there is one more component called kubectl. This is very, very important. It's nothing but Kubernetes command line utility tool. Command line utility to interact with the cluster. Means to deploy the pods, to scale the pods, to delete the pods, to delete the deployments, whatever. you will be connecting to the cluster via kubectl. This utility is common, or this is very important for any cluster. Your cluster could be on-prem, your cluster could be on EKS or Azure, or your cluster could be a local cluster, whatever it is. kubectl is the command line utility used to interact with the cluster, right? So these are the 4 components we need to install now. On every node, we need this component. So we'll install these 4 components. And by the way, here, this is what actually we are doing. This is worker node, or this is master node, and this is worker node, right? We are creating cluster, a 2-node cluster, right? And then we were connecting, or we will be creating pods by running commands on this manager itself. That's what we are doing. kubectl create pods and commands, right? This is master node. We are doing this one. We are going to do this now. This is one way. Or else, let's say I may have some other machine, my laptop. I may connect to this cluster from my laptop using kubectl and run the deployment. This is also possible. You don't need to get onto the master and create all the pods and all. You can also connect to the cluster from outside, which is actually, this is the reality. This is how we do. We will do that as well for EKS, but for now we will be working on the master itself. Am I clear with the difference? Is the difference clear, or any questions, confusions?
It's clear.
All
Clear.
right, thanks. Okay, let me try connecting back. It might be available now. Yes. See, do you see the host name is updated? Can you all see that? Master node. Now, let's connect to this as well. Here also you can see host names are updated. Perfect. Now we have to install these 4 components to interact with the cluster kubectl. First of all, to create the cluster kubeadm, kubelet, the Kubernetes agent which runs on every node, and the Docker runtime. All these 4 components should be installed. You cannot install all of them with yum. Yum is the package manager, but you should have the yum repositories configured, right? So first we'll configure yum repositories for it using this. Like, we are going to create the Kubernetes repo file. If you remember, we have seen this in the beginning. I'll show you again. Let me first show you. Go to etc yum dot repos. Do you remember Jenkins repo we created, so that it will have the repositories from where Jenkins should be installed? The same we are doing. Kubernetes repo is created. See, we have added this content into this Kubernetes repo file. See, this is a repository URL from where Kubernetes, kubeadm, all of them can be downloaded. That's what we did. So do that on both the machines. Kubernetes repo file is created. Once it is created, let us install the components. See, Docker, kubelet, kubeadm, kubectl. But install the specific versions, right? Above these versions, there is some incompatibility. So just let us install the specific versions of the components on every node. This is all. Master. Right? Once it is installed, we'll start kubelet, we'll start Docker. All of that should happen on both on master and slave. Start the components and enable the components. Enable the components. So enable the components means during startup, these components would be started and running. Enable Docker, enable kubelet. Perfect. We have installed all the components. Now it's a cluster creation time on the master node. Now, whichever node you want to make a master, on that node, you have to run kubeadm. So kubeadm init, right? And the advertise IP address of master, and it should ignore the errors regarding number of CPU and memory. Do you remember, like we were talking, it needs 2 vCPU and 2 gigs of memory, but we can't use it. So to override it, ignore those errors of CPU and memory. That's all. And pod network. Pods will be assigned with some address, right? If you want, you can assign some IP address range. Your pods will be assigned with that IP address range. We don't have our own network here, so you don't need that flag. You need only this much. But correct the IP address. You have to put the IP address of the master. So let me get the IP address of the master again. Right now, copy this command and run it on the node, whichever you want to act as a manager. This is the one I want to act as a manager. Let's create the cluster. But another thing is, to create the cluster, it would be connecting on some port called 6443. That port should be opened. So let me do one thing. Go here, security, inbound rules. Otherwise, it would just fail with the timeout. All TCP. I'm allowing all traffic. All traffic. You may add the port specific, or else this should be fine. Let's wait. See, it started. Okay, so cluster is created. It clearly says that your Kubernetes cluster control plane has successfully initialized. To start using the cluster as a regular user, see, I created the cluster as root user, but it's not that you will be having always access to root. You should be using as a regular user. For that, you should do this. I'll talk about it in a while. Before that, see here, it has again given a token. See, on 6443 port. So whichever node you want to act as a worker node, okay, you have to go to that node, come to the worker node and run the token. Actually, it's not copied properly. I'm just taking into a notepad. Hmm. So this should be added to the cluster as a worker node. See, it says, yes, this node joined the cluster. Check the command with kubectl on control plane. Every command should be executed from the control plane, from master only. But rather than doing it from root, let us do it as a regular user. But how does any other user connect? See, listen this carefully. Whenever a cluster is created, the cluster will create a file called kubeconfig file, or else here in this case, it created a file called admin.conf. It has created in HC Kubernetes admin.conf, which is used for authentication to the cluster. Means to connect to the cluster, let's say from my laptop or from anywhere, you should have this kubeconfig file. It's admin.conf, but we will be copying it to as kubeconfig folder. Means we'll create a folder called .kube. In that again config, we will copy this folder, copy this file. So that's what we are doing. As a regular user, means switch to EC2 user. I would like to connect to EC2 user. As a EC2 user, create a folder called .kube, right? And then copy the file from root user, which is admin.conf. Copy it as a config file inside the kube folder. That's called kubeconfig file, and provide ownership of that file. Provide the ownership to EC2 user. Now, if you go to, there'll be a kube folder, a config file created, which is a copy of admin.conf. This is useful for authentication. Now that EC2 user have got this kube config file, EC2 user can connect to the cluster. kubectl get nodes is the first most basic command to list the nodes in the cluster. Do you see that? Both the nodes were ready, like master node and worker node were connected, but still they were not yet connected. I mean, they were not in the ready state. Why and all we'll discuss. Is this much clear, everyone? Connecting to the cluster as a regular user, is this clear?
Yes.
Also, you might be wondering, where is that API server? Where is that controller manager, HCD and all, right? Like here, we install them as a pods. kubectl get pods minus A. A means all the pods. See here, you have got API server, controller manager, kube proxy, scheduler, HCD. Do you see all the components were running as a pod? Got it? So, yes, these are the components. With the kubeadm, you have got all those utilities, all those components configured. And again, core DNS components are pending. They are not running. Only once they are running, you will see nodes as running. It means it's still pending state. For them to get running, we need to install some network plugin. What is that network plugin? There are different network plugins. One such plugin is Calico plugin. What is the supply command? You will understand little later. It's just nothing but applying some standard manifest file which will install Calico plugin. So install this Calico plugin. Now if you see the pods again, get pods. See, you will see Calico pod started now. Once they are running, once they get started, your nodes will be started, obviously. Let's wait. Until then, you can see get nodes will be not ready state. Let's wait. Wait for the pods. If you want to just keep watching, add -w. So you will see the change. See here, they were just getting changed. See, Calico plugin is now running. So initially pod initializing, then container creating, isn't it? Inside the pod, you'll have containers. So first pod initializing state, then container creating, container initializing, and then running. Now they are all running. I can stop this and just simply check pods. Yes. Do you see? All of them are in running status now. Now, if you see the nodes, yes, they are in ready state. This is the cluster creation step by step. You should do this carefully. You should be cautious doing this. Master node is ready from 6 minutes and this is available from 4 minutes. Now, okay, fine, nodes are created. All the components are running as a pod. Okay, fine. Let's say I want to deploy some address book image, or else I want to deploy some Nginx image, for example. Right? How do you do that? You have to create the pods. Always declarative approach. You have to create a manifest file. In reality, in real time, yes, manifest file, manifest approach. I mean, the declarative approach is preferred. Give me 1 second. Yeah. So the manifest file approach is preferred, but for certifications or for quick execution, you also have the imperative commands. This is the command kubectl run. This will create a pod. Run. Let's say sample pod. Name is sample. Image name is Nginx. For example, I'm showing this will create a pod with one container in it, which will be coming from Nginx image. Pod is created. How do you see the pod? See here, sample pod. If you use -a, it will show you pods from all the namespaces. Namespaces we will learn later. If you just do pods, it will show the pods in default namespace. Our sample is created in default. We will talk about namespaces separately. Just understand, yes, pod is created in the default place, and this is how you see it. It's running. Pod is running. If you want to see more details, describe pod sample. It will show you all the details, including on which node it's running. See worker node 1, because we have only one node, obviously it will go there. Running status, every pod will be assigned with some IP, the container ID, the image, and at the bottom, the interesting part we have learned. Do you remember the architecture? First, scheduler will schedule it to the worker node, right? Then kubelet, which will take those instructions, kubelet on the worker node, pulling the image, successfully pulled the image, created the container, started the container. Do you see the architecture we learned in the events? Scheduled, pulled, and created and started the container. All of that is done by kubelet. Initially, it got started by the scheduler, right? So that's how you can create a pod. Get the pods. If you want to see where it is running, output by. See, it will show you the node where it is running also, the IP address of it and so, and the age of the pod. If you want to delete the pod, kubectl delete pod name is sample. That's how you delete the pod. This is the imperative approach. A quick way of creating it may be useful in the certifications or quick processing, but in real time, always prefer the declarative approach. What is the declarative approach? Through manifest file. So, through manifest file, do you need to create the how do you create a manifest file? How to write the manifest file? You don't need to worry or learn that line by line. Through practice and experience, you gain grip over it. You have the official documentation, Kubernetes documentation. Kubernetes documentation is always preferred. Just a second. I'm sorry. So go for this Kubernetes documentation and get started. Yeah. So whichever you want, I want to create a pod manifest file. If you search with pod, you will see here. See, Kubernetes is an open book exam, be it a certification or in the interview. Means you are not expected to write line by line without seeing. But anyway, like in some interviews, it was also asked through practice and hands-on, you get used to that format, right? So just if you go here, also one more thing is in the certifications, you should be referring the official pages only. Means when you search here, you will also see something, some blogs might be also popping up. You should be careful not to click them. If you click them, you will be kicked out of the examination. It was a proctor monitored. It would be a strict proctor monitoring for Kubernetes. So you should be careful about it. So if you just come here, yes, here is the manifest file. You can just copy it. And by the way, one more thing is you have line by line explanation here. Like, of course, not line by line, but what it does. But we will discuss what are those. You may you may give any file name, right? This is what you have. Okay, so what is this API version? API version is the standard line. That's and by the way, this is YAML key valued pairs. This is the key, this is the value. And the API version is the standard version of the Kubernetes API, V1, and the kind of deployment is pod, right? And then metadata. Metadata gives information about the pod, like name of the pod and all. This is fixed. This kind is Kubernetes object. So it could be pod, it could be deployment. There are some standard objects. First, let's begin with pod. Metadata gives information about it, like name of the pod. Whatever name you want, you can provide that name. Let's say I would like to give the same Nginx, same sample pod, right? And then specification deals with what is inside the pod. What is inside the pod? Containers. Name of the container, let's say sample container, right? And then image, they provided some tag. I wouldn't provide the tag. It could be latest, or else if you want, you can provide the tag. And the port where that application is running. That's all. Let me make it more clear. Like this metadata deals with information. Specification deals with what is inside. These are mandatory parameters in the manifest file. What are the mandatory parameters? API version, kind, metadata, specification. Specification deals with what is inside the pod. This is your pod. Inside this, you have a container. This is the container. This is the sample pod. Of course, container name is sample container. And it's coming from image name, which is running on port 80. That's all. Same thing happens. How do you apply? How do you run the manifest file? Save this. kubectl apply. That's what is apply. -f file name. That's all. That will create the pod. Same like we have seen before. Get pods. Describe the pod. Sample is the name I have given. Again, everything is as usual. Got it both the ways, imperative approach and declarative approach, but always prefer declarative approach only in Kubernetes. And then comes the next part of, okay, we have created the pod. Let's say I want 10 Nginx pods. How do we create it? Do you write this part 10 times? How do you scale them? How do you access it from the browser? All of that comes in. There comes deployment objects, service objects, and so on. Is this much clear, everyone? Any questions in this manifest file or any questions anywhere?
Yeah, okay.
Set up your cluster and do hands-on till this much, and we will continue from here tomorrow. And one more thing is, this is the reason I told you, we are using Docker images and creating the pods, right? Within that, it's nothing but container. So to understand this thoroughly, you should understand Docker. So that's the reason we have learned Docker thoroughly. So it should help you understand Kubernetes very well. The backend is again Kubernetes. Okay, there is a question from Alan. Hi, ma'am. Just want to check if any company will they use both the Docker Swarm and Kubernetes or any one. It depends, Alan. Like let's say in test environment or in dev kind of, they might be using Swarm. Later on prod, it could be Kubernetes. So it depends. Or else for some applications, some projects, they might be using Swarm, for some Kubernetes. There is no rule, only one should be used. All right, then we'll close here and we'll continue tomorrow. Thank you all. Good day. Bye, everyone. And another thing is just stop the instances and you can get them started tomorrow whenever you need it. All right, then. Thank you all. Bye.
Thank you.